general theme is, can you make an electron from a photon or a photon-like object? And I've been thinking about this for quite some years and tried different things. This is a work in progress, but it feels like it's getting somewhere. Okay, let me just read these. Entangled double-helix superluminal photon model is defined by defined structure constant, and it has inertial mass, m equals E over c squared. So I have a model of a photon. It's the first thing. I'll very quickly summarize it. A double-helix photon. It's got a positive and negative charge that are circling around each other, and they're moving superluminally in order to move forward at the speed of light. So it's a superluminal, a double-helix photon model. And the quantum vortex electron, just a summary, I'll go through it, is when these two half photons split apart, separate when in the presence of an atomic nucleus, each one goes and immediately forms an electron or a positron. So that's the general idea. And it can be a continuous process. And these are both articles that are written at my website, which I can tell you. Okay. So this is what I just said. Double-helix photon model composed of two oppositely charged superluminal, I call them superluminal energy quantum particles moving in a double helical trajectory. And these energy quanta are held by the Coulomb attractive force between the two superluminal particles. Charge of Q and minus Q, which is not the same as the electric charge. This is what it looks like in a simple way. The two particles, actually the particles are point-like, so those are exaggerated just to see, but the actual superluminal quantum particles are point-like, moving in a double helix. And this is a sort of an angle view, and this is sort of head-on, but this is a spin 1 photon as seen from the front, made of the two particles sort of looking like this. Okay. These are just the equations for each one of the half photons. The position and the momentum coordinates. X and Y are the transverse coordinates, and Z is the longitudinal coordinates. You can see that the amplitude is lambda over 2 pi for each of the half photons. And it's moving forward at the speed of light. The momentum, transverse components, h over 2 lambda, h over 2 lambda. Okay. These are the half photons. So each one contains half of the momentum of a full photon. Also, in its transverse direction, it contains half the momentum. These particles are moving at 45 degrees, so it turns out that the longitudinal component of the momentum is equal to the transverse component. And for each of the half photons, therefore, it's h over 2 lambda, because the momentum of a photon itself is h over lambda. And the full, the z component of the half photon momentum is also h over 2 lambda in the transverse direction. But two of them together will add up to a total momentum of the photon of h over lambda. This is the second helix, so just mathematically they're opposite each other, moving in a double helix. How to get the magnitude of each electric charge? You just set the Coulomb centripetal force between the two particles equal to the, basically the centripetal force, you can say, which is the rate of change of momentum, force equals rate of change of momentum, and just going through that calculation, it comes out, just saying it very pretty straightforwardly, as the electric charge square root of 2 over alpha, where alpha is the fine structure constant. It turns out it comes right out of the math of calculating the Coulomb force of attraction that will produce that centripetal motion. 16 e square root of 2 over alpha mathematically comes out to 16.6 electric charges. So it's bigger than the electron or positron charge. But it comes out precisely that. Here's a summary. For the given equations, the opposite electric charges, Q and minus Q, are calculated to have a magnitude Q with E square root of 2 over alpha, 16.6 E. Alpha is the fine structure constant, 1 over 137.04 of QED. And this charge is independent of the energy, frequency, or wavelength of a photon. So every photon will contain that charge, the highest energy to the lowest energy photon. Using those equations for the two half photons, if you calculate the spin of the combination, the x component of the spin total for both together comes out 0. You can calculate it, or you can kind of see by symmetry that it would be the case. The x and the y components of the spin are 0. The calculation of the z component, the longitudinal component, when you do that calculation just by standard calculation of the z component is x py minus y px, and you do it for both of those. It comes out h bar. So this is just to show that the model itself, it has the correct parameters for a photon. What's the speed of the superluminal quanta? If you take those equations that I showed you and calculate by the Pythagorean theorem the x component squared, y component squared, plus z component squared of velocities, it comes out the c square root of 2. So each of those superluminal charged particles is moving at the speed of light times the square root of 2. They're moving forward at the speed of light. They're also moving in the transverse direction at the speed of light, but that makes a superluminal motion combination of c square root of 2. The total momentum, you just add the two z components of the momentum of each half photon, and you get h over lambda. The distance between the two particles comes out from the formulas, lambda square root of, lambda over pi. That's the radius of each helix is lambda over 2 pi. Excuse me. But that's the radius, but the separation of the two is like the diameter of the helix, so that's twice as much, and that's why it's lambda over pi, the diameter of the helix. Here it is, looking at it again. I'm proposing that the two particles are quantum mechanically entangled that form a single photon, so that although they're moving separately, they're actually part of the same quantum mechanical function. So I'm not trying to say that this is to replace quantum mechanics. I'm proposing that the two particles actually are quantum mechanically entangled, just like when an electron-positron pair are produced from a photon, the electron-positron pair are quantum mechanically entangled. So they certainly would be entangled within the photon itself. So the idea of having the double helix photon suggests a straightforward mechanism for electron-positron pair production. The charged superluminal quanta, if they're sufficiently energetic, for example, to the minimum energy for electron-positron pair production would be 2 mc squared, which is like 1.022, I think, MeV, or more. Okay, we'll create an electron-positron pair. So when that happens, the charges of the 16.6 plus or minus, they have to reduce to 1 and minus 1 electric charge, because that's what the charge of an electron-positron is. And by reducing the charge from 16.6 to 1, the Coulomb force is reduced by a factor of 16. That could, if it happens, that could essentially throw the two particles apart because they don't have enough attractive force to keep them together. So that could help them separate as separate electron-positron. How would you test this? There's more coming, but how do you test if you can find any evidence in pair production of a charge of 16.6 E? If somehow microscopically looking at pair production, if a photon has 16.6 E, and that is being transformed into 1 E and plus or minus 1 E for electron-positron pairs, then the evidence of 16.6 E, which is that E times square root of 2 over alpha, would seem to be pretty strong evidence for this kind of model. Okay, I've proposed in other articles a way to calculate the inertial mass of something just by its change of internal momentum. If you relate the change of internal momentum as dp dt is the change of the momentum of the object, and divide that by the acceleration, that basically comes out Newton's second law, F equals ma. F equals dp dt, and a, and you divide that, you solve for m, which is the inertial mass. If you do that for the photon model, for the two half photon models, it's 2 times the dp dt over the centrifugal acceleration. Each of those dp dt is equal to omega p of the transverse component, and centrifugal acceleration is r omega squared, where r is the angular frequency of the photon. That reduces to finally E photon over c squared. So it's another way to show that the inertial mass, I'm not talking about the invariant mass, but the inertial mass of a photon is the energy of the photon divided by c squared. And other different derivations have shown this also. I think it's kind of accepted that photon does have that inertial mass. From general relativity, mass is energy, and therefore photons should also have inertial mass. But it's sort of consistent with other things. So these two equations of the superhelix, the double helix, are consistent with what are the known properties of photons. Okay. Well, if you have an electric negative and positive charge separated, there's going to be an electric potential. Those are attracting, and if you just use the, you can find out what is the negative potential energy because you know the distance between the charges, and you know what their charges are. Okay, so the electric potential, and if you take the ratio of that to that's the U, find the ratio of that to the total energy of the photon, okay? So you're looking at the ratio of the potential energy to the total energy, which is h nu. What does that come out? It comes out, so here's U over E. U is just the potential energy of two charges separated by the distance. Divide that by the energy of the photon, h nu, which is hc over lambda. If you go through that calculation, it comes out -1. So that the potential energy of separating the two charges, it's attractive, and so that's a negative potential energy, but it comes out equal in magnitude to h nu of the photon, which to me was a surprise. I wasn't expecting such a sort of a simple result. Why it's negative? Because it's an attractive force, but it does seem to show that there's the frequency of the photon is related to its potential energy. And that some kind of potential energy is stored in a photon. Okay, now the idea is that a double helix photon can form an electron-positron pair if it's a sufficiently energetic double helix photon, which requires an energy of 2 mc squared for the electron or more. Okay, so this is the proposed model of an electron that you get when you have a double helix photon at the minimum energy of 2 mc squared for the photon, which means each half photon has energy 1 mc squared. That's going to form an electron. Now, the interesting thing is that I found it quite interesting, is a 2 mc squared photon has a frequency of half it has the frequency of the Zitter-Bewegung frequency of the electron, because it's 2 mc squared. If you set that equal to, for the energy of the whole photon, then the half photon comes out to be half of that, But the frequency of the half photon is the same as the frequency of the photon because they're both going together. So the half photon, which is going to become the electron, has a frequency of the Zitterbewegung frequency of the electron. And if you take one, and what's the wavelength of that half photon? It's the same as the wavelength of the photon of energy 2 equals E equals 2mc squared. So the wavelength of the half photon is, it turns out, a half a Compton wavelength. For 2mc squared, the energy corresponds to a half a photon wavelength. So a half a photon wavelength is going to, of the half photon, the idea is when it separates from the double helix, it's going to curl up because separating from the photon which stabilized its motion, it's an unstable particle by itself. This superluminal energy quantum is unstable, and it's going to find the stable position that it can do by itself, and that is to curl up into a closed helix, basically, which has the form of it is a closed helix whose wavelength is a half a Compton wavelength. Compton wavelength is h over mc, so it's half a Compton wavelength in its radial circumference. The helical axis has a radius of a half a Compton wavelength. It has a frequency of the Zitterbewegung frequency, 2mc squared over h. So that Zitterbewegung frequency was first found in the Dirac equation by Schrödinger, and it was never directly measured in a photon, in an electron, but indirectly the Zitterbewegung frequency has been measured in some very low temperature experiments a couple of times, that it's considered to be an actually experimentally measurable thing, but not so far directly in the electron itself. But so this, and it's a closed helix, and this is the superluminal energy quantum is moving along the surface of a horn torus. That's mathematically when this particular half photon, whose radius is half a Compton wavelength divided by 2 pi, it turns out to be h bar over 2mc, which is the kind of standard number that's associated with the radius of the electron. But it's the radius of the helix, but it's also the radius of the torus, from the center of the torus to the center of the axis. So that it comes out to be a closed torus, or a horn torus, moving superluminally along the surface. The only time it reaches is not superluminal is when it passes directly through the center. It's calculated, it comes out exactly c, just at the center point. Otherwise, its maximum speed is c square root of 5. Okay, that's 2.236 c, and then it slows down as it loops through the speed of light, and then it speeds up, comes around to the maximum, to the equator, maximum speed again, square root of 5 times c, and so it's moving around like that, and this is along the surface of a horn torus.
Just to be clear, a horn torus has a nearly closed center.
Completely closed. You can't see through a horn torus. The two sides of the donut are exactly touching at a single point. And that's the horn torus. So it's considered the simplest torus. Usually, electron models are not say usually, often made of a photon-like object which has 1 Compton wavelength, and to get a spin 1/2 in the model with a 1 Compton wavelength photon-like object, you have to make a double loop of the 1 Compton wavelength, so that a half loop is a half a Compton wavelength, which actually does produce the Zitterbewegung frequency of the rotation, but in a way it would be unstable because each time the 1 Compton wavelength photon comes around the first time, it's 180 degrees out of phase with itself in terms of wavelength.
No, it's not.
Okay.
Because you've also got the very phase, which is exactly in phase.
Okay, that's the question.
Yes.
So, but in this particular model, the 1/2 Compton wavelength, then it repeats again, and so it's stable with a 1/2 Compton wavelength internal wavelength. Okay. What does that half photon, I call it quantum vortex electron model, look like. These are the X, Y, and Z components of it. You can see that the radius of the horn torus is lambda c over 4 pi, which is the same as this h bar over 2mc, which people often talk about. And this is the form of a Zitter-Bevegan torus. It's both oscillating vertically and horizontally at the same frequency of the Zitter-Bevegan frequency. Lambda c is that Compton wavelength. The Zitter-Bevegan frequency is the angular frequency. So this is a sort of artistic depiction of two half photons coming in, constituting a composite photon, double-helix photon, reaching a atomic nucleus somewhere around here, which sort of destabilizes them, gives them a kind of a push, and the atomic nucleus gets pushed backwards, but the destabilization separates the two half photons each into one half photon, and it would presumably very quickly form into the next possible stable position, which is this closed loop which is stabilizing itself with a 1/2 wavelength internal radius at the Zitter-Bevegan frequency. Now, my model from some previous work, because I used to think that an electron was a spin 1/2 charged superluminal photon. Okay. An electron, that was my general idea, but the problem was photons are not charged, they're not superluminal, and they're not spin 1/2. But I learned that De Broglie, in around 1934, proposed that a photon could be a spin 1/2 half photon, two of them. Okay, he didn't say if they were charged or not. He thought they would be maybe like Dirac particles. But so when I heard about that, which was only last year, I thought, oh, what I've been calling a spin 1/2 charged photon is really a spin 1/2 charged half photon. And that gave me the idea I should really look at my sort of original work of forming a photon from a single uncharged helix, which would be itself kind of unstable and didn't really work, but it was the best I could do at the time, make it a double helix. And it turned out that I had actually proposed this double helix model of the photon in 2002, because I was experimenting, how could it be stable? I published it in a Dutch blog in a simplified form, but it was the same model. And then I left it thinking that there's no evidence for a composite photon. And so I went in the direction of a single helix, uncharged particle. But so I had done earlier calculations, but one of the results of this model is that as the electron or positron becomes relativistic, the diameter of its circular radius actually decreases with time. And that's because it's composed of a spin 1/2 half photon of more energy. More energy means shorter wavelength, means shorter radius. So this is a resting electron, and this is showing a side view of the path of the superluminal charge. And this is the circular radius of the axis. Okay, but this is predicted quantitatively to decrease as 1 over gamma squared. The central circle is 1 over gamma squared as gamma increases, but the radius of the electron itself in its orbit turns out to decrease only as 1 over gamma. That's kind of interesting because the faster it goes, the smaller the circle becomes. It becomes smaller faster than the radius, which is also getting smaller. So the electron is getting smaller as 1 over, basically 1 over r, with this additional 1 over r squared effect, which kind of washes out with very high energies. And so this is a relativistic electron. This is the path of the speed of light circular center, And this is the actual path of the superluminal energy quantum as it's moving along. This is relativistic, this is more highly relativistic. I've got two examples here in the side view, but I also have a front view. Look at end on, and the electron is coming towards you, the electron model. That's the central circle moving at the speed of light. So as you go to a larger gamma, this circle decreases as 1 over gamma squared. You can see it's getting smaller, smaller, smaller. And then I magnify the whole thing because you can't really see what's going on graphically. So from this, that actually looks like this, magnified. You see the circle, which was this, has become smaller as 1 over r squared, and this is the motion. It's a Zitterbewegung motion, but it's coming together into basically a singular circular motion. So out here, the central motion has kind of been essentially gone to 0, much faster than the 1 over r. So this is a spin 1/2. A half photon moving at the speed of light with a smaller radius given by 1 over gamma of the energy of the electron. So that 1 over gamma actually is very similar to what's necessary for a high energy electron in electron scattering experiments where they find the energy is the size is about 10 to the minus 18 meters. Well, for the energies that they use, about 30 GeV, that's approximately what's predicted by the 1 over gamma relationship for the size of the electron. So, but there's other evidence even for a standing electron that it can also have a very small radius. Demelt, I think, had a single electron 10 to the minus 22.
It just looks linear at that energy.
Yeah.
But
remember that the particle itself is point-like. So and that's where the charge is. Okay, so you could be scattering off a point-like charge even though you're at very high energy.
Well, the point is what you actually measure is that the thing scales. So what point-like means is not that it's a point. It means that the thing doesn't display any size variation.
Okay.
And for that to happen, all it needs to do is shrink in that way. So that's okay.
That makes it point-like by itself.
Yes, that's all you need.
That's all you need.
Okay.
Don't assume that the thing is a point.
Yeah.
Maybe a point-like is good enough is
Point-like
basically
requires
what you're
two
saying.
Different things, yes.
And finally, could this idea of a double-helix photon, which has a certain size and a certain momentum, how does that compare to the prediction of Heisenberg's uncertainty principle? Oh, okay, that question is coming. So, first of all, is this consistent with Maxwell's equations to have a photon-like object that's charged, moving superluminally? The light itself is moving forward at the speed of light. So the question is this physically an acceptable model, even though the actual charges are moving faster than light that make a photon? So to be determined. Well, I should say that the double helix photon model was proposed independently about 3 years after I proposed it by an Italian mechanical engineer named Oreste Carapo, and he put it on his website in 2005. And no, he said he conceived the idea in 2005 and put it on his website in 2008. Okay, but exactly the same results with the quantitative double helix and the same charge. And he didn't know that he wasn't the only person who had thought of it. Okay. So does anything have to be reevaluated about Maxwell's equations to consider this double helix photon model? And about the Heisenberg uncertainty principle, which says that for any particular dimension, the RMS value of the x coordinate and the momentum coordinate is greater than or equal to h bar over 2. That's the Heisenberg uncertainty relation for each dimension. Okay, and if you do the calculation for each of the half photons, you calculate the RMS value for the size of the photon and the momentum of the photon in the transverse direction. You calculate those and multiply them together. It comes out h bar over 4, which is just under the limit of the Heisenberg uncertainty principle by a factor of 2. But the thought came to my mind, is the Heisenberg uncertainty principle dependent on the fact that you can't really know exactly where that superluminal energy quantum is? It's within that helix. And the uncertainty of where it is in the helix almost accounts for the Heisenberg uncertainty principle itself. So that's a thought. So here's my wife and I in Paris a few days ago having breakfast. A really nice breakfast. And I thought that I would include that. I thought that might be something that would let you know about myself a little more. This is Debbie. She's a social worker in Santa Rosa. Fantastic. Okay. Thanks very much. Do I have time for a comment? Yes.
We might like to summarily discard the Gauthier photon model for a number of reasons, but we do know that there is some kind of M-theoretic topological brane influence on standard model matter, which we know little about. And we know from EPR that there is an instantaneous influence associated with that. From our look at it from Euclidean-Minkowski space, that could be a reduced influence, so we could see it as a superluminal artifact. So I think there is some reason for seeing this model develop under that influence. Thank you.
Yes.
That is plausible at the first glance, but it is not correct, because if you apply the Lorentz transformation for time and for frequencies, for such a case, for a particle or for a system which moves with speed of light in relation to another system, that's a very special case for the Lorentz transformation. But if you apply it correctly, then you can live with an internal motion, which is the speed of light. You can assume that the motion within the photon is the speed of light. The whole photon moves with the speed of light, and the photon still has an internal frequency. That is not so plausible at the first glance, but if I calculated it, because I was interested to understand how this works, if you apply the Lorentz transformation in the right way, then you will see that there is no need for superluminal internal motion. And that would be good, because it is a big challenge to physics to say there is something superluminal. If you can avoid it, we are in a much better situation. And you are in that better situation if you apply the Lorentz transformation. In my recommendation, I can also give you the calculation if you want. But if you calculate it in this way, you will see you don't need superluminal, and you can leave all the rest as it is in your model.
I think, thank you. The question may be, can you apply the Lorentz transformation to this superluminal particle?
Yes, yes.
It's not the same as a normal physical particle that moves at the speed of light, or a photon that moves at the speed of light. So it may have its own mechanics.
It's a geometrical process. And special relativity is, in this case, a geometrical process, yes? And this geometrical transformation has the result, in this special case, that you can have internal speed with c, and the whole photon can move with speed in the longitudinal direction. It works together, and it does not cause any logical conflicts. It's not visible at the first glance, but you have to apply the Lorentz transformation in a proper way, and you have this solved. And you can, if you solve this for your model, many things are much easier, I think, in your model, and you can stay with this.
You have to apply it also to the electron model as well, because it's also superluminal.
I think I completely agree with all that.
Okay.
And I also do not think that it will destroy your model.
Yeah, he's absolutely right.
Yeah.
I mean, you don't need the superluminal part of it. You can have the helix. You can't take something that has a non-zero divergence and take it faster than light with a proper Lorentz transformation without going to infinite energy. And you'd lose all of those problems if you did that. So
maybe
I disagree.
Yeah.
But anyway, I think we're going to ask Richard to take a bullet for the team. We're about 15 minutes behind
That's fine.
schedule, and continue the discussions with him at the coffee break. So.
Thank you very much.